Hi dear students, in today's class let us study about the decay of current in RL series circuit from the chapter DC currents from the paper Electricity and Magnetism for 3rd semester BSc Physics students. Myself Shivakumaran working as assistant professor in physics. In the previous class we had discussed about the growth of current in RL series circuit. We had derived the expression for the same which is given by I equals I naught into 1 minus e power minus r by L into t. We also had discussed about the time constant which is given by lambda is equal to L by R. This is RL series circuit which consists of source of EMF Xi connected in series with inductor of inductance L and resistor of resistance R. A plug key K is included in order to switch on or off the circuit. After the circuit is completely charged, it starts discharging. While discharging, the circuit looks like this. Now let us apply Kirchhoff's law. Then we get minus L di by dt, which is the induced EMF at L equals Ri. Or by rearranging the terms, we get di by I equals minus R by L into dt. Now in order to obtain I, let us apply the integration. Then the limits being I naught and I for I, because the current is decreasing or decaying from I naught, that is the maximum value of the current. Here the time starts from 0 and it reaches some instant of time t. After integration, we'll get log I on LHS and t on RHS, that we see in the next page. That is log I to base e equals minus R by L, which is constant, into t. The limits are being I naught and I. After applying the limits, we get log I to base e minus log I naught to base e, which is equal to minus R by L into t. Now this is the form log A minus log B. Then it becomes log A by B. So ಅದನ್ನು apply ಮಾಡಿದಾಗ ಇಲ್ಲಿ log I by I naught to the base e equals minus R by L into t ಆಗುತ್ತೆ. Finally, by taking analog to this expression, we get I by I naught equals e power minus R by L into t. Otherwise, I equals I naught into e power minus R by L into t, where this I naught is equal to Xi divided by R. This is the maximum value of the current. The curve, the graph looks like this. The current starts decreasing exponentially from I naught like this. Let us take an example. A coil which has an inductance of 40 millihenry and a resistance of 2 ohm is connected together to form a LR series circuit. If they are connected to a 20 volt DC power supply and disconnected after reaching the maximum steady value of the current, the question is, how long does it take for the current to decay to its half of the maximum steady state value? Andre, how long does it take a time? ಎಷ್ಟು ಟೈಮ್ ಬೇಕಾಗುತ್ತೆ for the current to decay to its half of the maximum steady value? Maximum steady state value is I naught, half of that is I naught by 2. Therefore, current I should be equal to I naught by 2. Otherwise, I by I naught is equal to half. The transient current is given by I equals I naught into e power minus R by L into t. ಈಗ ತಾನೇ ಡಿರೈವ್ ಮಾಡಿದ್ವಿ. Finally, ಇಲ್ಲಿ ಈ ಒಂದು ವ್ಯಾಲ್ಯೂನ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, we get in the place of I naught by 2, I naught cancel ಆಗುತ್ತೆ. Therefore 1 by 2 equals e power minus R by L into t. Taking the inverses, we'll get e power plus R by L into t equals 2 ಆಗುತ್ತೆ. Finally, after simplifying, we get the time equals 13.8 meter per second. Likewise, you can solve the problems. There are some of the questions. What will be the maximum value of the current for the same question? The answer is given. It is 10 amp. You can find it out. The second question is, what will be the value of the current at one time constant during the decay? Decay ಆಗೋ ಟೈಮಲ್ಲಿ one time constant ಆದರೆ ಅಂದರೆ lambda is equal to L by R ಆದಾಗ ಎಷ್ಟಾಗುತ್ತೆ ಕರೆಂಟು? ಇಟ್ಸ್ ಈಕ್ವಲ್ ಟು 3.7 amps. ಅದನ್ನು ಕೂಡ ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೋದು. Third question is, what will be the value of the induced EMF after 20 milliseconds? 20 milliseconds ಆದಮೇಲೆ EMF ಎಷ್ಟಿರುತ್ತೆ, ಎಷ್ಟು ಇಂಡ್ಯೂಸ್ ಆಗಿರುತ್ತೆ? The next question is, what will be the value of the circuit current in 2 time constants during the decay? 2 time constants ಆದಮೇಲೆ ಎಷ್ಟಾಗುತ್ತೆ? circuit current value. ಅದು 1.35 amps, you can find out. And the last question is, how long does it take for the current to decay to its 37% of the maximum steady state value? ಅಂದರೆ 37%ಗೆ ಇಳಿಬೇಕಾದ್ರೆ ಟು ಇಟ್ಸ್ 37%, ಅಂದರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂನ ಐ0 ಇದೆ. ಐ0 ನೆಕ್ಸ್ಟ್ ಏನಾಗಬೇಕು, ಇಟ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು 37% ಆಫ್ ಐ0, ಅಂದರೆ 0.37 ಐ0 ಆಗಬೇಕು. ಹಾಗಿದ್ದಾಗ ಟೈಮ್ ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ? ಸೊ 20 milliseconds. ಇಲ್ಲಿ ತನಕ ನಾವು ಏನೇನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಆರ್ ಎಲ್ ಸೀರೀಸ್ ಸರ್ಕ್ಯೂಟ್ ಡ್ಯೂರಿಂಗ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್, then derivation of current during the decay, transient current curve. Thank you.